Hey folks, Chuck Black here. We're doing 52 weeks of Python. We are in week number 38 and we are beginning our discussion of Flask. Now, this Flask discussion is probably going to take a few weeks. In fact, I can tell you the lesson that I intended to be this one is actually going to have to be two different lessons because I got towards about 2/3 done and I had over an hour of class recorded already, and so I'm separating that into two. So this one will be probably closer to 45 minutes or something like that, which is average, so that'll be good. But I will shortly after this be doing, I guess, week 39 probably is what I'll call it, and it will be the second half of this one. What am I talking about? Well, I'm talking about this simple application that you kind of see a little bit of on your screen here. I have devices. These are actually not devices, but they're host type of devices, I guess you'd say. These are hosts on the network that I have discovered, and I am keeping track of whether they are alive or not, and I'm updating things, and I'm printing this nice user interface, which is just a terminal window that keeps updating with information. Now I have not only this display Python program running, but I have a monitoring program running as well. That does all the hard work of discovery as well as pinging other devices to see if they're there, pinging all the devices and updating their status. And the Flask thing right here, this is my Flask application. Let me scroll it down to the bottom so you can see it actually is getting requests from both this particular application, this host display application, and from this host monitor application. So you can see that it's updating things. How is it doing that? Well, this picture kind of describes it a little bit. Let me make it a little bit bigger so you can see it. You can see that there are a number of different components here. There's really three components. One is the Flask host server, which basically sits there and gets requests. Another is the host display that displays this information, and the last one is the host monitor. So there's three different things that I'll be talking about. In this lesson, I'll be talking about the host server, but I will give an overview of Flask so you have a general idea of what it is, how it does what it does in general, how you make use of it. And I'll point out that not only is it useful for very small applications, there's very little code that I had to write in order to implement this nice stuff that you're looking at, but also I used Flask when I created this Quokka thing, which if you don't know what it is, it's basically a network monitoring and a little bit of diagnostic functionality for your network. It's written in Flask. Don't worry about the busyness of this slide. I'm just highlighting different technologies that are part of it. If you're not familiar with Quokka and you feel like you're getting a little bit more familiar with Python, or maybe you're there already and you just didn't know about it, I do have a full set of Quokka code walkthroughs that talk about all of these different things. I've pretty much covered just about everything that Quokka does in those walkthroughs. There's something like 18 of them or something like that. Anyway, I do use Flask for that as well, but we're going to talk about this simple, small little application and what it does and how it does it. And for this particular week's lesson, we're going to be looking at the server once we get done with the overview. So, hope you enjoy it. Let's get started. Okay, so let's get started talking about Flask. Now, I thought that instead of showing you a picture and showing you a definition of Flask, the first thing I would do is describe to you what you're looking at here, since you may have been interested based on what I posted in Twitter and the picture that I showed. So this is my little itty-bitty Flask application that is discovering hosts in the network. It's monitoring their availability, and in this particular example, as you can see over here on the right hand side, I've augmented it. I have two different versions. One's the simpler one without this, but I added this, which is, it shows the open TCP ports. So I'm not only monitoring the availability of that device based on ping, but I'm also doing a scan of the device and determining what TCP ports are open. Now in Quokka, I do a more thorough scanning of the ports in order to find TCP and UDP and IP and to find out more about the operating system and things of that nature. But for this little example, I just used the more basic scanning mechanisms that are available, and I am displaying those there. Now you can see stuff is running here. What you're going to see in a second is some of these will become light green. Those will be the ones that have just changed. If you look closely, you'll see that the last herd has been updated for those. And the next time that it prints, there will be another segment. Yeah, it's got these right here. And then probably the next time that it refreshes, it will be the bottom ones. And then it'll go back to what it was before, which is unhighlighted. But let me show you what is going on here. There's basically three things happening. The first thing happening is this right here. This is the output from my Flask service that is running. So I've written a little Flask application that basically serves the purpose of being kind of a rendezvous point where it stores the data and it provides a RESTful API for getting this information that you see displayed down here, for setting this information that you see down here, for updating the information that you see down here, and it also has a delete endpoint, but I'm not doing any deleting at this point in time. Probably if I saw that something was read for a long enough point in time, I would delete it, and then if it came back, it will get updated. So basically that is what this Flask application is doing, and I'll show you the code for that in a minute. Now over here you see that this is plugging along also. This is where all of the work is done, or at least most of the work is done. This is what is actually going out and monitoring the devices. So this is a Python application that I've written that basically goes out and reads all of the devices that exist here, and then it goes through and it pings them and finds out if they're alive. And so you can see here this one up at the top. I can tell you that's my wife's laptop, and it's running Windows 10 Home, and apparently it doesn't respond to pings, but I was able to discover it during my discovery run, and so it exists here. What will tend to happen when people turn off devices, or when my wife goes off to work or whatever, then you'll see things turn red in here, and that is an indication that they didn't respond to the pings. But that's what this is doing. And then periodically, I think every hour or so, it goes out and does the port scan. Why does it do it every hour? It does it every hour simply because it takes a long time to scan all of those ports. It's scanning port 22 through 1024. So even though it's very fast in what it does, using the tool in order to do that, it does take a bit of time. So anyway, and you can see it just ran its discovery process again to see if anything new has been discovered. And yeah, I can't remember how many we had here. I think probably everything that's going to be discovered has been discovered. Oh, but we see that one of the devices, my Google Nest, that's actually in my office, has gone down. Now, one of the reasons that things go down is because there's the ping process does not wait very long for the response. So periodically you see reds. And I can tell you that this is actually my laptop that I'm running on. So it came back as red, and it does that periodically. It is pretty maxed out with my VM running and then Windows running and everything. I'm pretty much maxed out at my 16 gig of RAM limit. So periodically that does not refresh right away. But let's see. Anyway, that's basically what this is. So that is a brief overview of what you're looking at there. Now let's move over and start to talk about what Flask actually is. So let's talk about what Flask actually is. Up here, I'm at the Flask documentation page where it describes what Flask is, and you can get to tons of documentation from here, as you can see. The definition that it gives of itself is reasonable. It says Flask is a lightweight, WSGI web application framework. You can pronounce that however you want. It stands for Web Services Gateway interface or something like that. It's a standard for doing web applications in Python. And basically what this is saying is that Flask is going to be a web service that will start up and allow you to define endpoints. Those are the URLs that people call into on your application so that it can be called. So basically what it's going to do is it's going to start up and then it's going to wait until an HTTP request comes in, and when the request comes in, it's going to get routed into your code. What does an application look like? Well, this is pretty simple. You can see right here there's only, 8 lines or so and 6 lines of code. Basically, you're going to import Flask. You're going to create the Flask application. You're going to define the URL. In this case, the URL is just a slash. And then you define your function, which is going to handle that URL. So when this is running, when somebody points their browser at the appropriate port and gives a URL of basically nothing, then what's going to happen is it's going to print out hello world or whatever it does. I don't even know what it does, but that's basically what it does. How do you run it? There's a number of ways to run it. You can just run it as a normal Python program, but the approved way of running it is like this. This is for, I'm not sure if they mentioned whether this is for the Mac. On my Linux system, I say export Flask app, and you'll see that in just a minute. So what does this look like visually? What does my application look like visually? Well, I've drawn a picture of it here, and let me make it a little bit bigger in case it's hard to see, and I'll try to do that without closing it. So this is my little picture, host discovery and monitoring. That's all that my little application does. I have a Flask application running. Remember in the last little segment I talked about the 3 different pieces. The one piece is my Flask application. This is the thing that has a web service that's running. It will have a REST API, and that will be listening for calls. And I show here that I have a little bit of data stored here, and you'll look at my code and you'll see why that's a bad idea, but I'll explain that and we will enhance that in the future. I have 2 little Python applications. One is host display. Oh, let me just show this to you first. That's the output from that is this, and you can see here, as you might expect for a web service, what are we printing out? We're printing out web requests. So you can see I'm getting a lot of GET requests. I'm getting PUT requests. Those are going to be to update the data. And you can actually see some of the parameters that are getting passed in on my puts. So that is my web service right here. And if you were looking closely, then you probably noticed that this is doing a new line at the same time that this is doing a new line, because this is my host monitoring application. So let's go back to that picture. I always lose it when I do this. My picture here, the host monitoring application, what does it do? Well, it runs discovery periodically to discover new devices, and we'll see how it does that. And it also pings the devices. And then every time it does that, it goes back to the web service. This is my host server Flask application, and it updates it using these HTTP type requests. If it's going to update it, it's going to do a put. If it's just getting the thing so that it's beginning to go through the process of iterating through all of the devices that it knows about, then it's going to be doing a GET. And so that's what that actually is doing. So let's go back here. That's the monitor process, and we're looking not at the port scanning. If you see over here, I'm running the actual simplest one, which doesn't do any port scanning. It's just discovering devices and monitoring the device's availability. The third application, the little Python thing, first was the Flask web application service. The second is the host monitoring. And the third one is the thing that displays it. And all this does, and I've drawn this arrow because that is what it's doing. It's basically making a request and getting all of the data back to put into the display. So keep this picture in your mind here. I'm going to go back to this, and you can see this is the host display application. This is my host monitoring application, and this is my host service application. The three are working together in order to provide this output and to keep the data updated. So this is my little application. I am in this series of discussions where we're going through Flask. I am going to talk about the Quokka application, and some of you may have come in that don't know what Quokka is. Let me show you this picture. This is Quokka. Now I'm showing all of the technologies here. So there's JSON being used. I'm using SCAPI and Nmap. I'm using Napalm and NC client. I have threads going on. But basically, and that makes this slide busy. Oh, and there's YAML up here. It makes this slide busy, but look, fundamentally, I have something that is not that dissimilar. Here's my Flask application. It has a REST API. Where am I storing the data? Well, with Quokka, I'm storing it in a database. What's going out and talking to the devices? Well, and the host and the services? Well, I have threads going in my actual Flask application, and those threads are independent of the RESTful API. They go out and they monitor devices and hosts and services, so I don't need a separate program in order to do that. I have these workers that do things that require root access, like for doing SCAPI and Nmap. And then I have a user interface, and I'll show you the actual Quokka, if not in this particular video, but I will show it to you elsewhere when we begin to talk about how I'm using Flask in this environment. But just so you know, and I want to reiterate this because they do mention this in the Flask definition. You see here that says it's a lightweight web application framework. It's designed to make getting started quick and easy, but it says that you can scale up for complex applications. I actually worked on an application that used Flask in an environment that scaled up to thousands of devices in a WAN environment, and it was using Flask in order to do that. And my Quokka application, while it's not huge, and I am monitoring services and devices and hosts, it's clearly bigger than my little host application here, but while it's not huge, it is using the larger application framework that's requested. So we will look at that. But let's get back and look at the code that implements this stuff right here. So before we look at the code, just really quickly, I figured it might be useful if I show you how I run these things. So I'm going to do Control-C from my display. I'm going to do Control-C from my host monitor. And now I'm going to do Control-C from my Flask. And let me clear this out so that maybe it's a little bit easier for y'all to see. All right, so first thing I'm going to do is I'm going to start Flask. This is my command. I say export Flask app equals hostserver.py Flask run. That will start Flask running my application, which is called hostserver.py. Now, as I mentioned, all it's going to do is it's going to sit there and it's going to listen for requests. And you can see it's listening on port 5000. That's what it does by default. So it's just going to sit there forever unless we do something. So the next thing that I'm going to do is I'm going to start the user interface, and that is host display. So it's just a Python application, nothing special about it except it does the HTTP requests. And you can see there's actually nothing. It's got the table, but there's nothing in the table here. So it's not, doesn't have anything to print out. Now the next thing that I will do, and you can see actually I've done a get here to get all of the hosts, and it's returning no hosts. So you can see that HTTP requests are coming in. So now let's start the actual work going. This is my host monitor now. Notice I have to run it in sudo. That's because I use, in this one, I am using SCAPI to do the discovery of devices using ARP-ping in the network. So I'm going to start that. You'll see it's doing this SCAPI stuff. If you recall from what we did before in this class, then this should look familiar. I just copied the code directly from that. And now we look here and we're beginning to ping these devices, and we've discovered the devices. And we're starting to get the cool, well, I think it's cool anyway, the highlighting of the things that have changed. You can see here the ones, really only thing that's getting updated is the last heard, although once again, Amazon and Lenovo Yoga, like we did in the first one, they've turned red because I was not able to ping them, and that's probably because it's on the hairy edge of me timing out faster than I should, perhaps. So when it goes through, it's going through the next every 15 seconds. Well, after a 15-second break is when it goes through, and it does this again. And you can see, let's see, I got rid of the Amazon badness, and probably by the time this refreshes again, the Lenovo Yoga is good, and these have all been updated. So this last heard is nice because it helps you to see what actually has been talked to. And you can see right now we're retrieving the host. That's doing a get to get the hosts, and now we're going through and pinging and updating them. So what I should see here is I saw a get along with a bunch of puts, and you're beginning to see this get updated as well. Okay, like I said, let's look at the code. All right, so as I said, let's look at the code, and remember this code is always available for you out there on GitHub. I do update it regularly, so you can listen for any changes, but if you go and pull down the latest, then it should have this stuff. I think I've made one tiny change this morning, but that's about it, and I'll probably update it again later. So the code is out there. Now we're going to start by looking at M05 Flask. Now I have created last night, which was Sunday, just so you know I'm working hard on your behalf. Yesterday, actually Saturday and Sunday, I created another version of Flask Port Scan, which has the same host stuff, except I added port scanning. And if you recall at the very beginning, I showed you the output that was like this, but it had ports, open TCP ports, and that's what I added there. So if you're curious about the difference between those two. But we're going to start with the simplest situation, and we're going to look first at this host server. So host server, remember, is my Flask application. And you will notice that it looks pretty similar to what we saw in that documentation page, where they basically just imported Flask, and then they go through and create a Flask application. And then let's skip down to here. They have all of these different routes, and so my routes for this host's endpoint, I'm going to allow the user to do a get or a post or a put or a delete. So there can be 4 different types of HTTP requests that come in, and I'm going to handle all of them. So before I get too far, let me highlight this and highlight this. So if you are not really that concerned about this, or you're not don't understand enough about computers and software to care about this, just remember that it's something that you shouldn't do. But for those of you that are aware, let me explain to you why I say this. You should not use global data in Flask. And the reason for that is this. So think about a web service. Your web services, whether it's Google or Amazon or whatever it might be, it's handling probably hundreds of thousands of requests every minute that are coming in. It doesn't handle them one at a time. It handles them simultaneously. And even though they have a server farm with a bunch of virtual machines running on a bunch of rack-mounted blade servers, etc., they're still going to be within a single server. There's going to be multiple threads coming in that are making requests. Every request that comes in on its own thread, and that means that you will have potentially somebody doing a post at the same time another person is doing a post. And that can be problems. And I'm not going to go into the details of why, but just agree with me for the moment that that can have severe problems when you have two people trying to write to the same data at the same time. It's a computer science-ish thing. You need to use something that serializes the writes. One of the things that you can do is use a database, and that's something that I will be doing when I augment this functionality. For right now, I only have one application that is actually writing, and so I've done this just to make it simpler for all of you. If you are thinking of taking this code and doing something with it, then I recommend you either use a simple SQLite database or you serialize the requests in some way. Okay, that's my soapbox talking computer sciencey stuff. For the rest of you, just understand, okay, this works for now, and it's cool, and it's a simple teaching thing, but you don't want to do this. Now, how big is this file? This file is actually only 44 lines of code, and you'll notice that, what is this? This is from line, line 5 to 12, so that's 8 lines are actually for my comment that says don't do this. So it's a pretty short file. There's not really much functionality here. In fact, all of the functionality is what you see right here. I can fit it on one page. This is my function that handles the requests that come in. If somebody does a GET request, I'm just going to return that global host thing, which is where I store all of this information here. If somebody does a post, what I'm going to do is I'm going to destroy everything, and I'm going to go ahead and get all of the information that they gave me, and I'll explain this in just a minute. And then I'm going to set global host equal to that. If somebody does a put, what am I going to do? Well, I'm going to update the one that they asked me to update, and they're going to pass in an argument, which is a query parameter that's going to tell me which one I need to update. And so I'm going to get the data for that, and then I'm going to update that one. We'll look at this more detail in just a minute. Delete. I don't even know that this works. I hope it works. I haven't actually tried it, but somebody's going to pass me in the host name, and I'm going to delete that from my dictionary. So let's look in a little bit more detail at what this actually does. Okay, looking at each one of these in more detail, let's figure out what's going on. Now, the first thing that happens is I say global host. I need to do that so that Python knows that I'm referring to this global host. Otherwise, it gets confused. Python doesn't do very well with variable names that you may define in here that may actually exist elsewhere. It's not that Python doesn't do very well, but because it is dynamically typed, it will quite often, if you do something like this, it will create a brand new global host. Well, we want it to be referring to this one global host that's a global parameter, it's a global variable. So that's why we have to do that. Now, let's look at these. I have if request.method equals get, if request.method equals post, etc. First of all, where does request come from? Well, request is something that I imported from Flask, and it is magically set by Flask when it calls my function here. So it's calling my function as a result of the fact that the request had this as its URL, and it was either a get, post, put, or delete. If it was something else, or if I didn't have that particular method, then it would automatically return an error for me. I don't have to check to make sure that it's allowed because Flask nicely does that for me. But it will set this request type thing, and it's going to set the method variable of request equal to whatever the user was going to do, and it will either be a get or a post or a put or a delete. So if the request method that came in was a get, and remember a get, that's what this application is going to do all the time. It's going to be doing a get just to get that data. So if it's a get, then what is it going to do? It's going to return global host. So let's pause for a second and appreciate what is happening here now. I can get confused because I've described this many times in my Quokka walkthrough, but one of the nice things about Flask in newer versions of Flask, I used to have to change global hosts into JSON data and then return the JSON data string. If I just return, with this version of Flask, if I just return a Python data structure that adheres to what Flask wants it to be, which is it needs to be, I can't remember all the details. I believe it needs to be a dictionary. You can't pass a list in here. It needs to be a dictionary. If you are passing back that, then Flask is going to do the conversion of Python data into JSON string for you. So it makes it very, very clean and easy to do. So here I am returning global hosts, and that is basically, you're seeing this. This is getting passed over JSON. Remember, if I pull this back up, this is my host display. I'm making a request. It's a GET request. My Flask service is going to go and get it, and then it's going to return it in JSON, and then my receiver of this, which is this application over here, is actually going to go through, iterate through it, and print everything out in a nice format. So that is what happens here. This is probably the easiest one of these methods. So I'm just returning that data. Hopefully that makes sense to you. Now, the second potentially easiest is a post. And the way that I've defined post, and you probably know this, but just to go over it, GET, of course, gets data. Post is usually used for creating stuff. Now, you can use these methods for whatever you want, but in my world, what happens when somebody does a post is I'm blowing away the existing data in my host file, and I'm building it anew based on what got passed in. Okay, so that is what my post is doing. And let's look at what I said. This code here, so I'm setting my global host to a dictionary, and then I'm saying global host equals request.getJSON, and it occurs to me I probably don't even need this line. I think I anticipated having to go through here, but this is going to change that JSON data into a Python data structure, and then it's going to set that equal to global host. So yeah, I'm almost positive that I don't need this. I'll go ahead next time we come back, and I probably will have deleted that. And after I've done that, all that I've done is I've updated that data. So basically in this picture here, I got rid of that. Let's see, here we go. What I did was I ended up blowing away this dictionary and putting a new dictionary in there. So that is what I'm doing. And yeah, so that is what I do with a post. So what happens when the user calls in with a post? Well, with a post, what we're going to do is we're going to blow away everything that existed in global host, and we are going to set it anew with the JSON data that comes in via the post. Now, I don't actually do post in this carnation of what I've created. I instead use a put, but if I wanted to reset everything and start from scratch, then this is what I would be using. Now returning, I'm not returning any data. I could choose to return the host table if I wanted to, but I'm not, and I'm passing back 204, which says it was successful, but there's no data associated with it. Now what about when the user does a put? Well, so now we're looking at something a little bit different. When a user does a put, in general, they're going to be passing in, well, always, they'll be passing in a host name. Now, put is used for update, and you can define update to mean whatever you want. Quite often, it will mean that the item in the table or in the database has to already exist. The way that I'm doing put, however, is that I'm updating, meaning updating the host, the global hosts table. And so what I'm going to do is I'm going to check to see if the host name is there. After I retrieve it, this is again my request. object that I get from Flask. If I do args.get and I pass in the actual query parameter name, that would be something that says hostname equals. If I look over here, I can see hostname equals Roku streaming stick. So that is what it's looking for, the hostname equals part. And it's getting whatever the hostname is. If I don't have a hostname, meaning it wasn't there, then I say, you've got to provide the hostname or I will not handle this. And so basically I send a 400 with an error message that says you must provide hostname on put. Now if I have it, then what I'm going to do is I'm getting something out of JSON that was given to me, but I'm assuming in this situation I was getting the entire host table. In this situation I'm getting just a single host. And what I'm going to do is I'm going to update it. Now what happens here if hostname exists? Well, it's going to point now at the new data that I have. So that's okay. What if hostname does not exist in global host? Well, it will create it. And so basically when I do a put, then if it is something new, like if I've done discovery and it's something new, then I'm not actually running this. Probably would look a little bit better if I'm running it. I just recently restarted everything. So you can see I have a smaller number of devices. As it goes through throughout the day, it does learn about new devices. So you can see the ones that get updated. In this situation, it's getting updated with the new time, the actual last heard time. So that is where I'm using these puts. I should see, here's a bunch of puts on my service. And here's my get, which may have been could have been from this particular, from the display. It could also be from the host monitor, because we'll look at that code in a minute. So that is what update does. There's a lot of updates going on. And the last one is a delete. And if we were given a delete, then we delete it from the table. And that's all there is to this Flask application. Everything else that we're going to look at from now on is going to be the actual users of this Flask application. So you can see the Flask application, if I look at this picture again, the Flask application is really, I keep doing that, Flask application is going to be kind of the repository for the data. In Quokka, you can see it's the means by which I get to the database through that REST API. In this situation, I'm just using local data, and my display is getting that data, and the monitor is both getting it and updating it as necessary based on it's doing the ping and doing discovery. So the next thing that we'll look at is this host monitor. Okay, so I've recorded sessions discussing the host monitoring functionality and the host display functionality, but that has ended up to be way longer than I like to have for my lesson. So what I'm going to do is I'm going to stop and review what we've talked about in this lesson, and then I'll create another lesson where I talk about host monitoring and host display. That will be the next thing, and it should be coming soon. But I do want to make sure that we understand what actually is going on here. So let's talk about what we discussed. The first thing that we did was we actually looked at this working, like you can see right here. So here's my display of the host information. So this is one actual application, Python application that's running and that's updating information. You can see that it's printing information about devices that are unavailable. It's got this regular green color for ones that haven't changed, and then the lighter green, which you saw just went away. That's when we come through, and usually it's changed because of the fact that the last heard is different, and you can see one right there. So the last heard is more recent than it was before. So that is the display piece. Over here we have the monitoring piece, where you can see I'm going through and pinging the hosts and updating them. Now they're actually periodically doing discovery as well to see if there's any new devices. So that is going on. And then this is the piece that we're actually looking at the code at for this lesson. And this is the actual Flask application that we've created. So the Flask application is basically sitting there listening to requests and responding to them. And as you can see, the requests in our situation are all puts and gets, but when we look at the code, we'll see that there's actually more that could be done. Now, we looked at the overview of what the actual structure looks like. It's pretty simple. We're running Flask with our host server, and it exposes a REST API. And we have data here, and I mentioned that we'll talk about storing data as a global variable not being a good idea, but basically there's a REST API that allows these gets and these puts to happen on that data. Now the gets and the puts, the monitor is doing gets and puts to update the data, and the host display is just doing gets to get this data and to print it out and to update it on its own screen, etc. So that is the general overview. Now we talked about how Flask, the definition of what Flask is, it's a web application service that's simple, but it can be expanded to something more, and I did give reference to the fact that when I implemented Quokka, I used a larger and more robust implementation of Flask in order to add database functionality. I have a user interface that's actually making use of the REST API to get data. I'm launching threads to monitor things. I am actually communicating with workers using RabbitMQ, and they're sending data back using JSON in HTTP, and I'm talking to devices using Napalm, NC Client, etc. So there's a lot of stuff going on there. Don't be overwhelmed by this, though, because you can make applications that are extremely simple, and that's what we looked at here. Now let's look back at the code that implemented the service. Now, just a reminder, not a good idea to have global data that is stored and referenced in your Flask application. That's why I say don't do this. In fact, like 1/6 or something of this whole code in here is saying don't do this. Basically, it's not thread safe. That's why, because every HTTP request that comes in is coming in on a different thread. And even if you don't understand what that means at a computer science level, you can understand, ooh, that sounds like it's bad, and it is a bad idea. So we store data generally in a database, or we have something else that serializes the request. But I'm doing it as simple as possible right here because we're all learning Python, so that's why I did it. Now, our implementation, if you recall, this is the URL that we defined. We said that we're going to use these methods. So Flask will nicely make sure that the request is one of these. A lot of times you'll see you only have a get, and it will reject attempts to post, put, or delete. So that's why that's helpful. This is the actual URL that we're making the request on. And so we have, we're referencing the global data. If the user does a get, we return that global host dictionary that has all of this information in it. Now notice one thing that's important is we're returning actually JSON data, and the Flask library is translating from our Python data into JSON. When there's a post, which I don't do, we blow away with the data that was there before, and we get the data from the JSON that was passed in. So we are actually taking our JSON data and changing it into Python data, and then that gets stored. Put is something that we do a lot, whether it's being discovered or whether it's being updated, and basically we need to get the argument, which is the host name, and this is how we do it. We get that argument. If it's not provided, then we say, there's a problem, and we return 400. Otherwise, we get the JSON data and we set our global host dictionary to that value with the key of the host name. And if it's new, it'll create it. If it's already exists, it will replace it. Delete, we don't, I didn't implement, I haven't even tested it, but this is generally what it would do. So that's what our Flask application does. It's just sitting there waiting for requests. And you can see as we print stuff out, I'm not even printing anything out here. This is Flask printing it out for me. And you can see here in this situation, here's a host name, and it's passing in that host name right there. That's my parameter on the put. So hopefully that makes sense. As I say, next time we'll look at host monitor and host display, but that's probably enough for now. hopefully you can absorb that, understand it, and maybe even put it to use in the near future. Thanks for listening.